Hey, welcome back. In this video, we're going to talk about overlap events, and we're going to add an overlap sphere to the drone. We're doing this because we want to get a reference to the character when the character overlaps with this overlap sphere. That way our drone knows who the character is, so later we can make it chase the character. So let's get started. Now I've closed and reopened my editor, and I see that I'm back here in the empty level. Now I'd like to open up my FPS level map whenever I open the editor, and I can configure my project to do that. I'm going to go to Edit and Project Settings and click on Maps and Modes. And here in Maps and Modes, we can set some default maps. We have an editor startup map and a game default map. The editor startup map is the map that we open when we open our project in Unreal Engine. And the game default map is the map that opens when we run our game once we've packaged it. So I'm going to set the editor startup map to my FPS level. And I'm also going to set the game default map to FPS level as well. Now, if I close the editor and reopen it, I'll open up to this map. Now I'm going to go to FPS level, and here we have our map. Here's my drone. And I'm interested in adding a sphere to the drone that we can overlap with. And that way, our drone can get a reference to the thing overlapping, which in our case is going to be the character. So let's go into Blueprints, Drone, and open the drone pawn. And here in the drone pawn, I'm going to click the viewport so I can see my pawn, and I'm going to add an overlap sphere. So let's go to Components, click Add, and type Sphere. Now we have two options. We have a sphere and we have sphere collision. What we want is sphere collision. So if I click that, I now have a sphere component, and I can see that it's down here at the root. So I can bring the sphere up to the height of the drone mesh. And of course, it's a little too small, so we can increase the size. Now, rather than increase the scale, I'd like to increase the sphere radius. That way, our sphere component can keep its scale at 1. Now, I'm going to click and drag the sphere radius to the right to increase it. And of course, we can adjust this as we're developing the project, but I'm going to make it pretty big like this. Now, we can hit compile, and if we go back to our level, we can see the sphere here. But if we start playing the game, we actually can't see the sphere. That's because it's hidden in-game. Now, our sphere component has a rendering section. If we scroll down in the details panel, under rendering, we have two checkboxes. One is visible. If we uncheck it, we can't see it, even here in the blueprint. So I'm going to leave that checked. And then we have hidden in game, which is checked by default. If I uncheck it and then press play, then I can see that sphere even when playing the game. So that could be useful for debug purposes. Now we have a sphere, and we'd like to create an overlap event. And we can do that by going into the event graph. And here in the event graph, with my sphere selected, I'm going to right-click and type on component begin overlap. And we see here there's an event called add on component begin overlap. Our sphere component has this event, and if I click that, I now have this event, and this event is designed to be fired off when something overlaps with our sphere. Now, we can select our sphere again and go down into our collision settings here in the details panel. And if we expand the collision presets, we see the collision presets is set to overlap all dynamic. And these are grayed out, but we can see that our sphere is set to overlap all object types. And our collision enabled is query only, no physics collision. So our sphere will never collide with something and impart forces on it or anything like that. It's set to overlap everything. And with collision enabled set to query only, it can generate overlap events. So back in our event graph, our on component begin overlap is going to be fired off when something overlaps with our sphere. We can test this out by simply dropping something into the sphere. For example, in the starter content, we have some shapes. Here's a shapes folder, and in the shapes, we have shape sphere. I'm going to drag this into the level. I'm going to move this over and bring it up so that it's just above the sphere. Now, in order to drop this into the sphere, we need to simulate physics on this sphere. So I can go into the details panel. Right now I'm selecting the instance of this static mesh actor. And scrolling down to the physics section, I can check simulate physics. This way, physics will act on the sphere, and we see that enable gravity is checked as well. So if I take my character and I'm going to rotate it to face the drone, that way we can see this as it's happening, I can press play, and there's the sphere. It dropped into our drone's overlap sphere. Now, what I'd like to do is make sure that our overlap event is happening. So back in the drone pawn, I can take the other actor and do something. I'm going to take this other actor and use a get object name node. Get object name returns the name of the object, and it returns a string. And I can use a print string node to see that printed to the screen. So I'm going to use print string and plug in that object name. Now, before we test this out, we need to make sure that we'll get an overlap event. So I'm going to go to our sphere here in the world, and in the details panel, scroll down to the collision section here. And rather than our collision presets being physics actor, I'm going to set it to custom. We have collision enabled query in physics. I'm going to set this sphere to overlap the world dynamic type. That's the type of our collision sphere here on the drone. It's a world dynamic object type. Now, if I scroll up a little bit, we'll see this checkbox generate overlap events. If I check that, and then I press play, then as soon as our sphere drops into the overlap sphere, we got that message printed to the screen, printing the object's name. There it is, static mesh actor 7. So we know that our overlap event is working. So we want to get a reference to the character once the character overlaps with that sphere. So what you're going to do is use this overlap event to get that other actor and cast it to FPS character. Once you've done that, you can promote this value from the FPS character cast node to a variable. Call this variable goal actor. So now we'll have a variable called goal actor, and we're setting that after casting the other actor in the overlap event to FPS character. Once you're done, you can use a print string node to print the goal actor's name using get object name. Pause the video and give this a try. Okay, so rather than just printing the name of the other actor, we first want to cast the other actor to an FPS character. So we're going to take other actor, we're going to type cast to FPS character, and get that. We're going to hook up the nodes, and since we want to store this character in a variable, I'm going to right-click on as FPS character and promote this to a variable and call this goal actor. So now we're setting this goal actor variable, and we can take this goal actor and print the object name from this. And of course, I need to hook up the print string node. So now if I hit play, we no longer get the name of the sphere that's falling. That's because the overlap event took that other actor and cast to FPS character. And this sphere is not an FPS character, so that cast failed. But if our character itself overlaps, now we see FPS character C1. That's the name of this particular character that we have possessed. So we know that our overlap event is working, and as soon as we overlap, our drone now has a variable storing the value of our character. So in summary, we've added an overlap sphere to the drone, and we set up an overlap event so that we can store a reference to the character once that character overlaps with the sphere. We're going to use this reference when we make the drone chase after the character. So we'll do that in the lectures to come. Great job. I'll see you soon.